This is the part 1 of Machine Learning with R series. In this section, we are going to set the benchmark for model selection and do some rudimentary explanatory data analysis. The dataset that we're going to use is called MEUs and it's in the library SP. Let's first load the data in our console and use the head function to view the first 6 rows of our dataset. If you wish to know more about this dataset, please visit this link below. Let's use the function library to load the package SP that contains our dataset into R. And we're also going to load the function coreplot into R. The specific functionalities will be discussed later. We use data MEUs to load the dataset MEUs into our console. And let's use head on the dataset to display the first 6 rows of our data. By using this function, we can see what are the column names of our data set and the storage types. For example, we can clearly see that land use is stored as a categorical variable, whereas the distance is stored as a numeric variable. Next, let's extract some basic summary information from our data set. We do this by calling the function summary. We can see that the summary function gives us the minimum, first quantile, median, mean, third quantile, and maximum value of each of the columns. It also shows the number of missing values in this column. For example, we can see that there are 2 missing values in the column OM, and there's 1 missing value in the column land use. We can also use sum is an A on our data set. This will give us the total number of missing values in the complete data set. You can see the number we have is 3, which matches 2 plus 1. For the purpose of this exercise, we simply omit all the missing values by calling the function na.omit. But if you wish to know more about how to treat missing values, you can refer to this site. After removing all the missing values, we can obtain a box plot for every variable except x and y. The reason why we exclude x and y is because these are coordinates, and there is not really that much numeric information we can get from the box plot of coordinates. This is the box plot. And we found that zinc, lead, and distribution.m has a more spread out distribution. After getting the box plot, next we would like to obtain the correlation plot for some of the variables. We do this by calling core, the function core. And we exclude these columns because these are categorical columns. We also use round to make sure that we save only 2 decimal places to make the plot more presentable. By calling the core mat, we can see the correlation matrix below. In order to better visualize the correlation matrix, we use coreplot. This is from the package we loaded in the beginning of this exercise, the package coreplot. From the correlation plot, we can see that strong negative correlations are marked with dark red, and strong positive correlations are marked with dark blue. From the correlation matrix, we can see that there are strong correlations between cadmium, copper, lead, and zinc. You can see it from here. It's all above 0.8. There's also very strong correlation between distance and distance.m. This is because they are measuring the same thing, but just in different units. Because our response variable is lead, and we found 3 variables are very likely to be significant, we draw a scatter plot with x, the predictors being the other 3 variables, and the response variable being lead. From the scatter plots, we can see that there are very strong positive correlations between all three variables and lead. However, the correlation is weaker as the predictor's values get larger. This is reflected by a more spread out distribution towards the end. Next, we are going to set the benchmark by building a very simple linear model using all of the predictors in our data set. The R-squared that we get from this model will be regarded as the benchmark for all our subsequent analysis. In R, the command to build a linear model is really easy. We just do it by calling lm and specifying the response variable, here being lead, and we use a dot to signify all of the other variables as predictors. We also need to tell R that these variables come from the data and we use. After building the model, we call the summary on the model, and it tells us some relevant information, such as the square coefficients, their significance, the residual standard error, multiple R-squared, and F statistics. From the summary, we can see that our R-squared is extremely high, almost 97%. This indicates that using the predictors in our data set, we're able to explain 96.64% of the variation in the response variable lead. However, once we take a closer look into the summary, we can see that only a few of the variables are significant. Note, the significant variables are labeled with the 3 stars at the end. But we're using many predictors. This means that some of the predictors are probably highly correlated. Thus, they add including one instead of the other, adds little value into our prediction. So for the next step, we're going to take a closer look into variable selections in order to have the strongest predictors so we can have a clear and simple interpretation. Thank you.